Welcome, and thanks for joining us for today's webinar on network design and best practices. I'm Ricky Pishoff, and I'm one of the technical training managers at SnapAV, and I'll be your moderator for today's webinar. Before we get started, a few quick housekeeping items. First, we will be recording the presentation as usual, and we'll send you a copy by email within the next few days. The email will also include the coupon code that was mentioned in the invite letter. And lastly, we are planning to have time at the end of the presentation for Q&A. So please feel free to send in your questions at any time during the webinar. You can do that by using the question and answer feature in the webinar control panel. Okay, now I'd like to introduce today's presenter, Aham Araksusi, who is the product category manager for our Araknis networking products. Aham, I'll pass it over to you.
Thanks, Ricky. Welcome, everyone. Thanks for attending this afternoon on the East Coast and noon time on the West Coast. So today we have a very general topic. It's about network design and best practices. We got a lot of feedback from dealers asking us, hey, when it comes to designing a new networking job, what are the best things or best approach or best practices that we need to take into consideration from an architectural standpoint all the ways to some tips and tricks. So that's what we will cover in this webinar. It won't take more than, I think, 30 minutes, and we'll have probably about 15 to 20 minutes at the end for some Q&A. So what we will cover this webinar is that how to break down a network design so you have a really good networking opportunity with your customer. How can you design it? How can you think about that design to break down the solution in your head and come up with a really solid architecture? And second to that, what kind of conversation you need to have with your customer? What kind of input that you need to get from that customer in order to get to that really good approach. Before we end the presentation, we have some exciting new product announcement for you, so stay tuned for us. Something very excited about, and we'll end up with some Q&A. Thanks for a lot of your feedback when you signed up for the webinar. I got to read all of the respondents' answers around what kind of pain points you have today. I did see a lot of topics or pain points that we covered in previous webinars, so please check those webinars, particularly those three. They are either on YouTube or Vimeo. So there's the Sonos VLANs and switches webinar we did last year. So we talked about how to do VLAN setup and deal with Sonos setups and all that fun stuff. And then we did fast roaming when we announced the 500, 700 access points, explaining how we deal with fast roaming on the access points themselves. And I believe last month we did the truth about Wi-Fi speeds, just to level set on what you should expect in the real world in terms of Wi-Fi speeds and how to level set that conversation with your customers. So today I will not dive into the details of each one of these three items. I'll leave it for you guys to go and kind of rewatch those webinars and brush up on that information. And we have a lot of content online in the product support tab as well. So like I said, today is all about the architecture. So how can you design a new networking job? How can you think about it from an architecture perspective? And I want to introduce something like it's really a building block mindset. If you want to have a really solid architecture, no matter how big or small the job, it needs to be scalable and it needs to be modular. So I will introduce kind of like a framework to think about for you guys. So we start with the ISP. So this is an ISP building block. So it starts with what you're getting in that house or what you're getting in that small business. Is it is a Spectrum service, is a Comcast service, is a Verizon service? Each service provider will have its own nuances that you need to deal with in your region. What kind of line is coming into the job? Is it a cable? Is it a fiber? Is it DSL? So that's one important external factor that is somewhat out of your control, but you need to be very aware of in terms of the design and the setup, because it will affect, this is the pipe that is going into the network. The second building block is your gateway. So this is your router, and you need to make sure that it is spec'd properly. The following building block is the core, then the access, then the devices. So the devices are the edge devices that will interface with the network. So these are your mobile phones, these are your tablets, these are your control systems, your VoIP phones. So this is what the end customer will interface with and will utilize. And this is how the traffic flows from top to bottom. So it goes from the ISP to the gateway, to the core, to the access, to the end devices. But also this is how the devices communicate with each other. So they go from devices to access to devices, or devices core to devices, or devices gateway to devices. And that all depends on, what kind of setup, how big the network is, if you have VLANs or not. So this is the framework that we would like to establish in your mindset when you start designing, and this is how it translates to a typical traffic path. So if you think about it, traffic coming to the internet or from the internet, it goes through typically a modem, and that's usually a third-party modem from the ISP. Then goes to the gateway, which is a router, then goes to a core, which is a core switch, then goes to an access layer, which is either an access switch, or in case of Wi-Fi, we have access points. And then that interface with the end devices. So this is the framework, and this is how we should dissect the network. So let's take an example of, let's say it's a typical network job that you deal with on average. So it's on average, we see from our customers that they will have between 50 to 100 devices on a typical network. So this starts with a lot of end devices. So those devices would be, control touch panels, a lot of IP cameras and NVR, a couple of printers, a couple of desktops, some Sonos or some, wireless streaming service, a lot of entertainment, TVs as well. You get a lot of personal equipment like laptops, smartphones, and tablets. We see now, and I'm guilty as charged, it's like every individual in the household will have at least 2 of these 3, if not all 3 or more. So you'll be surprised on how many devices on a typical network will be. And I see on average it's between 50 and 70. So this is a typical job, and this is the devices layer or devices block that is here. So here's how we want to, if somebody, you sat down with the customer and say, it's like, I need all of these things in a new job. And you start to dissect this network. So you start with the internet, so it's coming through a cable modem. And now you got this cable modem that plugs into our 300 series router. Then you got a 210 PoE switch. Then that 210 PoE switch as a core switch connects to a lot of access network devices, includes PoE switches or unmanaged switches or access points. So from an architecture standpoint, this is what we call hub and spoke architecture, or a router on a stick architecture. So the switch is the center point, the core switch. And this is a scalable architecture because now this 8-port switch can connect up to 8 access devices. So if you have 8 switches or 8 access points or a combination of both, you can get up to 8. But let's say the house or the network expanded, they installed 3 or 4 TV locations in the future, and now you are you're bottlenecked by the number of ports on that switch. All you have to do is come back to the job, swap this core switch with a 16 or a 24 port switch, and now you can expand your access layer to more than to about 24 access switches or access devices. So this is how you can scale this architecture, because you are bounded by the number of ports on that core switch. So same goes into those edge switches. So let's say we have an 8-port here, an 8 PoE switch port. Then you connect up to 8 cameras to it. So you're powering 8 PoE cameras from this 8 PoE switch, and 2 years down the line, the customer comes back and say, hey, I want to install a couple of cameras in the front or in the back of the house. And you say, right, I populated all my ports on this access switch. So Mr. Customer, in order for me to expand these cameras, I need to expand the PoE ports on that switch. So I have to swap the 8 port with a 16 port. And this way, it's one component change in the network that expands your doubles the capacity of your IP cameras. So I will go next layer by layer or block by block and see and share with you guys some of the tips and tricks for each of those. So we start with the ISP layer, and this is what we talked about is the modem. Usually comes in a separate box. Really, when it comes to modems, you have 3 options. Either you replace, or you bridge, or you DMZ. The replace option is our preferred method, and this is something that we recommend to all dealers if possible. Whenever possible, swap out that modem that comes from the ISP with the modem that you own. So this way you can get a higher quality modem, and you can guarantee its performance, and you own it. What we saw is that for cable modems, for example, so we are here in the North Carolina area, or even in the Midwest, when Spectrum, Time Warner, or Comcast, it's really preferred to swap those cable modems with something that you can buy off of Amazon. And Ares Surfboard is a really good modem, very reliable. It needs to rebooting every once in a while, but overall it's much better than what you get from the ISP. And also the way you can sell on the customer is that almost all those ISPs, when they put their modem in the house, now there's moving towards a recurring cost, or they call it a maintenance fee. So they can maintain it and do some firmware updates on it, and they charge the customer about $6 to $8 a month in order to maintain it. So that's a perpetual cost for the end customer. So replacing this modem with one-time $110 or $150 modem, it will pay for itself within a year and a half to 2 years tops. So that's something that's very important, and we prefer this method. But we recognize that sometimes you cannot replace that modem because it comes in a combo. So the modem is embedded in a router combo, and there's Wi-Fi in that, so it makes it a lot worse and a lot more tricky to replace. So what you will do in that case, if there's no way to replace it, your best second option is to bridge it. So keep the modem or the combo from the ISP and bridge it. Basically, it will act as a pass-through. So all you have to do is just make sure that you get the make and model of that combo. Call the ISP and tell them that their support staff, and tell them that you want to bridge it. Sometimes it's not fun to work with the ISP tech support, so you might want to resort to do some quick online research in the manufacturer's manual, because most of the time these are well-known companies, and see how can you bridge that modem combo and bypass it. If that combo has also Wi-Fi in it, it's advisable to turn off Wi-Fi in that device, because usually it's not in an ideal place to have a Wi-Fi device in it. How you can verify with this option is when you plug in the router inside that combo bridge, you should see a public WAN IP on the WAN interface of the router. So this is how you verify that this combo modem is bridged. Now, in the third case, which is you can't replace the modem, you have to deal with it, but for some reason you cannot bridge it. You can't find the option. You called the ISP and they said there's no way around it. You did some online research and you couldn't find anything to bridge it. The third and final resort that we recommend to dealers is to put it on DMZ of that combo device. And we've seen this with Verizon Fios. The problem is that you have to be aware of double NAT situation. Basically, if you go here, the WAN interface of the router is getting a private IP from that combo router. So basically, there's a mini router here in the cable, and it's having a private IP to the router, and it's getting a public IP from the ISP. So this is a NAT device, so it does network address translation from the WAN public IP to the LAN IP. Then the router will do translation from this LAN IP to another LAN IP. So this is what we call a double NAT situation. The problem with a double NAT situation is that you have to, if you want to do port forwarding, it becomes a little bit tedious because you have to do port forwarding on the first NAT device, then port forwarding on the second NAT device. The other problem is if you want to do remote access to any of the devices inside the network, it becomes also problematic because they have to go through 2 layers of NATing. Now with OvrC Pro and OvrC Hub, that problem doesn't exist because you SSH to OvrC Hub inside the network, and you can access other devices, local IP address or local interfaces easily. But if you do not have an OvrC Hub, remote access becomes a little bit tricky, and it requires some maneuvering in both the combo from the ISP and the router. So these are the 3 options that you have. We have some internal documents in our tech support for DMZing, and if you run into that situation, feel free to call our support line, and we will help you through it. Now the gateway layer, which is the router. So basically the router, what it does is it connects the internal network with the internet. So let's assume that this is the modem that you got and replaced. All it does is it's just a dumb device. Your router is getting a WAN IP address from the ISP, and the router is responsible for all that translation from inside to outside the network. So here are some general tips and tricks that you need to be aware of when you think about that layer, the gateway layer. Make sure you look at you spec the right equipment. Look at the WAN to LAN throughput. Our current 300 series router is capable of doing up to 500 megabit per second WAN to LAN. I know some of the high frequency questions that I get is like, hey, are you going to come up with a higher end router to do 1 gigabit per second for those Google fibers and the AT&T fibers, ISPs? The answer is yes. We're in development, but stay tuned for more information on that. The other thing that we start to see is that some of the dealers are more concerned about the security, and we start to see some of those unified threat management appliances being spec'd as the gateway device, which is great. Those level of devices are higher than the typical simple gateway in terms of just security, but you have to be very aware that once you enable all those security features, your throughput through that device goes way down. So if you go to the spec sheet, you have to look at the SSL IPS throughput. So this is basically the UTM device or the UTM appliance is doing deep packet inspection on encrypted traffic, which most of the modern applications use encrypted traffic to communicate, like Facebook. So they have to do a lot of processing on the local device in order to protect the traffic from any malware or any attacks. So what you typically see in a UTM appliance is that, for example, let's say you see a spec that is 1 gigabit per second firewall throughput. And you say, great, this is a great appliance. But paying extra attention to the spec sheet, you see the SSL IPS throughput is about 50 megabit per second. So there's a huge drop between not having security features and having security features. So just be aware, it's a good approach. Just be aware that you have to spec higher end equipment based on SSL IPS throughput. I think last time I checked with one of the dealers, he was looking at a company called SonicWall. and he was trying to see if SonicWall will have a good solution for his application. And we looked at the highest end model from a low-end series. It dropped from 1.5 gigabit per second firewall to about 200 megabit per second SSL IPS throughput, and that equipment cost him on Amazon about $1,800. So there's cost associated with the UTM appliance. Obviously, it's higher cost than non-UTM appliance, and there's also a performance degradation problem that you need to be aware of. The other thing that you need to be aware of is, or we highly recommend, is that use one LAN interface to the core switch. So this is what we call the router on the stick architecture or design. So basically, it's the local network, and you have the router sitting on one stick, which is one interface to the network. Why we recommend this architecture, even though the router has, most of the time more than one interface on the LAN side, is because a lot of those routers are not meant to handle LAN traffic properly. So a lot of those routers do not have spanning tree configuration. A lot of them, they do not have IGMP configuration. There is, LAN to LAN throughput. There are two ways to measure LAN to LAN throughput. One of them is layer 2, which is only Ethernet. The other one is layer 3, which is IP routing. So if you have to do multiple VLANs and you have to do inter-VLAN routing, your IP routing throughput through the router is not gigabit. So you have to be aware of those things when you connect multiple switches to the router directly. So that's why we highly recommend doing router on a stick architecture. The other thing that we recommend, since we're talking about routing, you talk about IP subnetting. So standardize on your own IP schema and document it. This is a very, very important thing. It will make your life 100 times easier in the future. So here's an example that I'm using. It's just an example. First of all, stay away, or I would recommend to change the default 192.168.1 network, because you end up with a lot of default network coming out of the box, maybe on the ISP combo box, or when somebody's VPNing into the network. So it's highly advisable to change your default subnet. So let's say I change my subnet to 192.168.100.x. It's a /24 subnet that will give me up to 254 IP addresses. There's plenty of devices that I can connect to this network. So an example of standardizing on my own IP schema is I say, hey, every job that I go to, the range from .1 to .19 is reserved for networking equipment. So this is .1 is the router, .2 is the core switch, .3 is another switch, so on and so forth. So these are the management IP addresses for those networking equipment. And I standardize on those across all my jobs. So if I have to remote access, or I have to local access, I don't have to waste time going through documentation or going through some previous notes on what the IP address of that device is. I know exactly what it is. It's always .1 for the router. It's always .2 for the core switch. It's always .3 for the edge switch, and so on and so forth. Here's another example from the IP schemas. Like I will start my surveillance equipment from .20 to .39. That gives me about 40 IP surveillance equipment. And I can say I always start with the NVR. So .20 is always the NVR. .21 is the first IP camera, 22, 23, so on and so forth. So that makes it standardized, and that makes it also very, very easy to follow in troubleshooting. And once I've done standardized on my own IP schema, I can also standardize on my port forwarding rule. So one of the very important items is that we highly recommend matching port forwarding rules with IP addresses. So let's take an example of this surveillance IP schema here. So say between .20 and .39 are my IP cameras, and I want to access one of those cameras remotely through a port forwarding rule. Let's say I want to access camera .30. So one of the best practices is that I start with a range of ports. Let's say 8,000 is where I start. Maybe I want to start at 9,000 on the WAN, and match the last 2 digits with the IP address of the device. So let me do a pen here real quick so you can see it. This is 30 matches 30, and so on and so forth. So actually, it's the last 3 digits should match the last 3 digits here. So if I have a device here that's 130, then my port forwarding rule is 8130. I'm using keyboard. So that's an example of a really best practice. So this way, when you want to remote access to a device, you don't have to even think about it. I know exactly, I'm starting always at port 8000 or port 9000, and I know my IP camera range start from 21 all the way to 39. I know that I start, for example, north to south. I want to access the 3rd camera from north, then it's going to be 23. Port 8023 is the the port that I need to access. It saved me a lot of time in troubleshooting, just plowing through documentation. The other final tip here is that, before final tip, is that VLANs, you have to consider about inter-VLAN routing. Some consideration when you have inter-VLAN routing, and again, if you want to dive into the VLANs, please watch our webinar about VLANs and read the documentation, the support tab. But one important thing that you need to be aware of is that Apple devices, sometimes control systems or streaming services do not play well across VLANs. An example of that, if you have an Apple TV on one VLAN and you have Apple devices like iPhones on another VLAN, your Apple services will not go across VLAN. You cannot do AirPlay across VLANs. You cannot do AirPrint across VLANs. It's going to be very, very hard. And we found that some control systems also, they don't scan across VLANs because they scan using MDNS technology, and it doesn't play well across VLANs. So be very aware when you do VLANs about inter-VLAN routing and inter-VLAN traffic. The final tip when you talk about routers is when you do speed tests, be aware that speedtest.net is not the only tool available for you. It is actually one of the least favorable tools that we recommend for dealers for a couple of reasons. First of all, it is flash-based, so if your computer is not up to speed in terms of spec, then your computer slows down the speed test. Your NIC card will slow down the speed test. The second reason for speedtest.net is the results vary by the test server. So make sure that you pick or test against different servers in the region, and you see different results there. A cool website, it's called testmy.net, is not flash-based. It gives you an average, an aggregate about your service. I think this is something that's a good alternative to speedtest.net. All right, let me clear these drawings. So we go to the core layer, and as we say, the core layer, our goal here is to make the network as quote-unquote flat as possible, which means that you want to minimize the number of hops between different segments of the network. So like I said, for performance purposes, for a lot of different reasons that we mentioned in the gateway layer, we would like to keep one core switch off of the router and then everything off of that core switch. It is not recommended to use multiple core switches off of the router. You might end up using this architecture for really large jobs for various reasons, but if you are designing from the scratch, it's highly recommended to use one core switch off of the router. If you use multiple switches off of the router, you run into issues with IGMP snooping on the router if it's not supported, spanning tree issues if it's not supported on the router. Your layer 3 traffic, LAN to LAN, is going to be less than gigabit per second. So it's really not a good situation. So like I said, make your network as flat as possible. Make it as a hub and spoke topology like we talked to. So everything is fed off that core switch. And in this layer, actually, a managed switch is better than an unmanaged switch for various reasons. And if you watch the Spanning Tree and Sonos webinar, we explained that when using managed switches, you can control the Spanning Tree algorithm, and you want your core switch to be the root bridge for Spanning Tree. So you want to force the network to get all the traffic through the core switch, not through Sonos. Here makes sense, and it's better than an unmanaged switch. And if you have access points in this scenario, I think a lot of the jobs will have access points. It is also recommended to use a managed PoE switch, and this is one of the reasons that we do not have an unmanaged PoE device, is because we would like to keep that control in a managed platform. The other thing you need to think about from a design perspective is you want to keep your hops. This is the jumps. So if your traffic goes from this switch to the router, this is one hop. You want to keep it to 3 to 5 hops maximum from end to end. Usually dealers don't think about it from device to device. They think about it from device to the internet. It's like, hey, I got 3 or 4 hops between my device to the internet. This is good for the internet traffic, but what about traffic going from a control touch panel to the control processor? That needs to be between 3 to 5 hops maximum in a good design. So that's why you have a flat network. We also recommend from a physical installation to color code different types of traffic if possible and standardize on that. Like I said, if you have access points, use a PoE switch in the core as a core switch, and make sure you pay attention to the PoE power budget. So an example for our switches, a 210 has half PoE power budget as a 310. So it depends on the number of access points in the job, and depends on the number of PoE devices in the job. You might want to select a 210 versus a 310. Like I said, from a Spanning Tree perspective, especially when you deal with Sonos, and we've seen lately some TVs, actually, they have some Spanning Tree problems. The Samsung TV and a Sony TV we ran into. A core switch needs to be the Spanning Tree root bridge. And when you have really large jobs, you need to start thinking about VLANing those chatty traffic. So if you have, a surveillance system, I would start with surveillance in a separate VLAN to begin with. Make sure you name interfaces on that core device, on the core switch. It will save your life when you go 6 months, 8 months after the fact, and you want to troubleshoot something. This is when, Oversee as a free cloud management tool is very valuable for you. It will take a couple of minutes of your time to go through Oversee and name each interface. Say, interface 1 is connected to access point, upstairs. Interface number 7 is connected to access point basement. That will help your life a lot. Now we go to the access layer. So the access layer is the layer or the building blocks from the solution that interfaces with your end devices. So that's an interface with your control touch panels, with your Sonos devices, with your TVs, with your end clients. So when they have their laptops or mobile phones. So there is a wired component, and there's a wireless component. And like I said, in a previous webinar, the last webinar we've done on the truth about Wi-Fi speed, and this is something we also documented in a blog. If you go to our blog, there is a big difference between the advertised speed on any networking manufacturer access point and what you should expect in real life. So an example, a 700 series access point that we have, of any equivalent access point that we have, will advertise 1750 megabit per second. The nominal throughput will be around 800 megabit per second. The effective throughput in real life, based on a lot of variables that you cannot control ahead of time, will be between 2 to 4 or 500 megabit per second. So there's a big gap between the two. Unfortunately, that's the nature of Wi-Fi. That's the nature of the standard. There's no special sauce between any different vendors for that. So make sure that you understand those limitations and make sure that you set the expectations right with your customers. So from the access layer perspective, unmanaged switches here they make sense from a cost effectiveness and just ease of deployment. And I would account for 20 to 30% port expansion in the future for any access switch, unless it's a really special case. So if you have a PoE switch, for example, as an access switch, and you have a requirement of 8 cameras or 7 cameras, I would not get an 8-port PoE switch. I would get a 16-port PoE switch just to make sure that in the future expansion, you are covered. It's really hard for the customer to come back, a year from the job, ask for 1 or 2 IP cameras to be added, and you come up with a quote that you need to swap your switch, and it's a couple $100 extra. So plan for it as expansion. Sometimes, we understand that you need to be on a tight budget. So just make sure that you account for that. When it comes to wireless, it's something we stress with our customers, that dual band APs, so 2.4 and 5 gigahertz APs, much more important than any cost effectiveness. So I would start with a 300 series access point at the very minimum. It's a dual band 2.4 and 5. The 2.4 gigahertz spectrum is a lost cause. It's really, really hard to get any meaningful throughput out of it, and it's getting even more scrutiny from the FCC. If you want to plan for the future, wireless AC is definitely the mainstream now. Wireless N is an old technology. If you want to do analogy for video traffic, wireless AC is the 4K, wireless N is 1080p. Use fixed Wi-Fi channels. So all the access points are auto in terms of channel selection. This is when your investment in a spectrum analyzer is very important, because if you do your job and you do spectrum analysis and you do site survey on that job, you will pick the right Wi-Fi channel for each radio interface that will have less interference, and you know what you're getting into. You will not rely on any external factors for that. And if 6 months from the fact the customer calls to say, hey, my Wi-Fi is slowing down, you can quickly do another Wi-Fi spectrum analysis and see what happened to that channel, and you can jump on a different channel. Heat map for fine tuning, and this is when your investment in heat mapping software will be very important to set the expectations right, make sure that you don't have any dead spots in the Wi-Fi coverage, make sure you measure the speed. So these tools will measure speeds at distance, and will get you get a really nice report for your customer to see what the expectations are. Name the interfaces. This is even more important to name interfaces than the core layer, because this is where you connect your Apple TVs, where you connect your touch panels. So naming the interfaces is very, very important at this layer. And this is really the genesis of our 110 Unmanaged Plus solution. This is why we believe our 110 series switches are unparalleled in the market, because you can do basic management features through OvrC. You can name those interfaces through OvrC rather than getting a dumb switch that you cannot name. So this is what sets the 110 series solution apart from everybody else in the market. Very, very, very important is to name the cables and test them. I can't tell you how many times we get calls from dealers thinking that the port is problematic in the switch. It turns out to be the termination is not good, or there's something happened in the cable is not tested or is cut off. Your cable infrastructure is the backbone that runs everything. So if your cable is good, your network is good. Now we'll shift the conversation, since we have that framework from a design perspective. When you sit down with your customer and you want to design a solution for them, you need to flip this framework upside down. So your conversation with the customer should start with the devices, and the devices you should ask, like, hey, how many family household, or how many members how many people there will be at that in that location, how many wireless devices in total or on average, how many wired devices they will have on average. You will add a lot of devices on the network from other solutions like your AV solution or your thermostats and what have you. what services are needed. If they want to stream music, they want to do some surveillance, you want to have some control systems, some lighting control. These are the normal steps that you go through with your customers. But as you go through them, you start to map out in your head what that network architecture should look like. I would highly recommend to do a quick site survey of the floor plan and do some initial wireless design to determine how many access points you need and where you want to place them. Understand what kind of ISPs are in the region, what kind of bandwidth they want to get from that ISP. And then, like I said, set the expectations about the Wi-Fi speeds based on our webinar. You will never get 1 gigabit per second Wi-Fi throughout the house. That is not going to happen within the existing standards, no matter what other vendors tell you. Explain the higher end, the need for higher end networks. Unfortunately, we still hear from dealers that there is a pushback around the quote for networking in a higher end job. It is very important for you as you face these challenges every day, because the network is the backbone of the solution. And if you don't own it and it's not up to speed in terms of performance and reliability, then the end user experience is not going to be as good. Then you do your design and you quote it, and hopefully you win the job. So this is what we think are general steps or general tips that you need to take into consideration when you sit down with the customer trying to design a job or quote a job for them. Now, before we turn into the Q&A session, we'll get to the product announcement phase of the presentation. We're super excited about the outdoor access point that we launched last week. Lots of great feedback, a lot of excitement, and we see it in the sales numbers. Today, I'm gonna announce a product that we release next week. So when we sat down and thought about those use cases that from a networking architecture perspective, we hear from the dealers that a lot of time they put their switches, especially those access switches, either behind the TV, and this is when a VersaBox will come into play, or they will have a structured wiring can in the job, and they want just to loop in and out that structured wiring can into a centralized rack, or they put it on the shelf, so they have a shelf in the rack, and they have a small device like a Roku. They would like to put another switch right next to it to save some space in the rack. So this is why we developed the new 110 Compact Series line. So this is an expansion on the existing 110 series switches. So it comes because it's 110, it's unmanaged plus, so it's full gigabit on the backplane. It's cloud managed through OvrC. Like I said, there's nothing like it in the market. It is very compact in design, and I will speak next on what are the benefits for that compact design. They are powered by PoE, so that's very exciting from an architecture perspective. When you have a core switch that is a PoE, and you have a TV location, and you want to put a 5-port that is powered by PoE, and there is a PoE out. So whether it's powered by DC or powered by PoE, the PoE out is 15 watts. So let's go quickly through the features. So Unmanaged Plus, like I said, it's an unmanaged switch, but cloud managed through OvrC. So it's DHCP out of the box. It grabs an IP, talks to OvrC. What you get in an unmanaged switch is you see devices online, offline. You can see the switches of offline or it's online. You can name the switch. You can name individual ports, and you can see the speed and duplex on each port. You can do firmware updates remotely if we do any firmware releases, and you can reboot the entire switch remotely. So we couldn't get to reboot the individual PoE out, but you can reboot the entire switch, and that by default reboots the PoE. So like I said, the compact design, it's very, very important. So we went into this product design from the mindset of let's design a product to go into a structured wiring can or into VersaBox. So you can see it comes in 5, 8, or 16 port option. They come with the mounting gear included in the box. There's no DC power supply, but you can see it mounts very neatly, very nicely into the structural wiring can, and you can put it here if you use our WirePath 1 cans, you can mount it on the platform. We've seen dealers during beta test that they do mounting on the side of the rack sometimes, and they do it under the desk. I'm pretty sure you guys find a lot of innovative ways to install this product. Like I said, it's PoE in, so it's 30 watts in, and there's 15 watts out. It can be powered by either PoE switch or PoE injector, or a DC power supply. The DC power supply is sold separately. It's 48 volt. But when you power through 15 or 30 watts, it's 15 watts only. PoE out, so you can power another localized device like an IP camera or a wireless access point, or you can power actually another compact switch from another switch by PoE. But be aware that the PoE out, when powered by PoE, is limited to 50 meters in terms of distance. That's about 150 feet. So that's it. That's the announcement. It's compact series. It's really our design process to go into the custom installation, listen to your pain points, and design a product around those pain points and give you a really valuable solution. And with that being said, I'll leave it to Ricky so we can go through some questions.
Alrighty, Aham. As always, great information on networking. We're going to go through a few questions here. I think most of these, everyone could get a little bit of good answers on some of these. Most of these we did cover, but I think some of them are pretty important that we maybe cover again. I'll start with this last one. We just talked about the PoE capabilities of these compact switches, and one of the questions, Aham, is this PoE plus device, or will it only pull 14.5 watts? So I think you covered that, but why don't you go in a little bit more on that?
It's a good question. So it is both. It depends really. So the switch itself, it pulls up to 12 watts of power. But when you utilize the PoE out, so if you're not utilizing the PoE out interface, then it's only PoE. If you start to pull power from that PoE out interface, now it becomes a PoE plus in. So 30 watts in, 12 watts consumed in the device, and 15 watts out, if that makes sense.
Okay, let's go into some general questions here, and a lot of these you actually answered some of these, but again, I want to reiterate some of these questions. I think they're key for the networking guys. Do you need a core switch if you only have one access switch?
Great question. No. In that case, when you have a really small job, and really small means that you can have up to 48 devices on a one switch that can act as a core and access switches at the same time, you do not need a core switch. This is really more of an expandable and scalable architecture when you have those larger jobs. But let's say if I have a small to medium sized job that I got, up to 48 devices only. They need no VLANing, or they need just to be plugged into one device. Then you can get a router, and from the router to a 48 port switch, and then from the 48 port switches all the way to end devices. That's very feasible.
Okay, you may have to pull up one of your other slides for this one, but I think it's key. Please discuss the location of the Oversea hub and why you would play.
Oh, great question. Great question. Let me go back to my architecture one real quick. Oh, here you go. So, great question. Your Oversea hub, since it's measuring speed and latency, ideally what you want to do is plug that Oversea hub directly into the router. This is the best place to put the hub because it will go only one hop to the internet, and also it will be on the top of the network to scan the entire network. So today, if you put the Oversea hub to the router, our existing 300 series router, you will see there's a significant dip into the reported speed. And that's a bug that we are fixing in a firmware update for the router that will be scheduled to be released by the end of the month. So in a couple of weeks, we will release a new firmware for the router. It's 1.0.5.34, and that will fix that issue, and you'll put the hub. Your next best option today is to put the hub into the core switch. Again, you want to have as accurate of speed as a measurement as possible, and you want to have as good of access to the entire network as possible. So that's a good question.
Okay, again, I think we covered some of this, but I just want to make sure that everyone understands. If there are only 2 switches on a network, are you saying we should have the layers stacked, one off the router and the other off the other switch?
It depends on your architecture, but ideally, yes. You do not want to have 2 switches off the router because you, like I said, you will end up with a situation where you have, let me go to this slide. When you have traffic going, if you have traffic going between those 2 switches, they will go through the router, and now you will have spanning tree issues, you will have IGMP issues. If you have any inter-VLAN routing between the 2, you will have performance degradation for sure. So ideally, you want them to be one off the other, one as a core, one as the access.
All right, so again, lots of questions about that. So just everyone's clear is that there should be one core switch and then other switches plugged into the core switch. So when you're designing your system, that's why it's so important to understand how many network connections you need to have to how many devices. So another quick question here. This is just a general question. What IP Finder tool do you recommend for Windows Computer? Any recommendations on that?
Good question. So we got a couple of options. Some of them are free. So if you are using Wi-Fi on the phone, I'm a big fan of Fing. Fing is a really good tool. If you are using, obviously, our OvrC Hub utilizes multiple tools inside the code to sniff the entire network and puts everything into your OvrC dashboard. If you just wanted something that is software on the PC, I think for Windows, there's a Windows IP scanner, if I recall that correctly.
All right, just a couple of more questions real quick. This one's on the compact switch. How small are these, and do they need any airspace?
They're quite small, so you can see them. They are on the website as coming soon items. Just filter on the left side, unmanaged plus, and you'll see them as coming soon. They're quite compact. You need some airspace going, just because they're fanless. They don't have any fans, so you need some ventilation going through the switch. But like for example, we during the design process, we thought that would be a good idea to do a drop-in installation in the VersaBox, similar to the WAP box. But unfortunately, that tight space is not recommended by the certification bodies because of air circulation, the risk of running too hot and catching fire. So that you do not want that to happen. So make sure there's a good amount of space around them and for.
Alrighty, another quick question. Can you talk a little bit about the proper use of the SFP ports? Restored. Can you hear me now? Sorry, I lost my connection for some reason. So the SFP ports, so 210 and 310 switches that we have, there are at minimum 2 SFP ports and a maximum 4 SFP ports when you have 48 port models. So those SFP ports, they are extra ports on the switch. They do not share any backplane with other ports. So they have dedicated bandwidth. So really an 8 port is a 10 port. But when it comes to
SFP ports, there are really two use cases that we recommend, or we see dealers use that for. So the SFP port, think about it as an empty slot that you can populate with either electrical RJ45 or a fiber SFP. So let's talk about the electrical RJ45. If you have, let's take this example. We have a job when we got a 210/16 PoE, and 15 or 16 of those PoE interfaces need to power 16 IP cameras. You still need a one interface to go back to the core switch. So that interface is you have two options. Either you lose a PoE port, or you get a RJ45 SFP and plug that RJ45 SFP and connect it to the core switch, and now you have 16 PoE ports going to 16 IP cameras. So that's a main use case. The other use case is, think about, for example, if this 5-port, or this, instead of the 5-port here, there's a 8-port 210, and it is in a guest house, but is really far. It's like 200 meters far or 300 meters far. Your Cat5 from an Ethernet perspective can go up to 100 meter tops per standard. So that is 350 feet. If you want to go beyond that, you need to go fiber. So if you will have to go fiber interface, then you would populate a fiber interface on the switch, in the access switch, and a fiber interface on the core switch, and now you have a fiber link between the two switches.
All right, we're about to run out of time here. I got one more question here. I think it's pretty relevant. We didn't talk a lot about the brand new outdoor wireless access point, so this question could come into play here. Also, by the way, on the wireless access, the new outdoor wireless access point, there's some really good videos on that product tab that you might want to take a look at. But this question just came in. Can I just add your new outdoor wireless access point to a customer's existing network? So I think, Ahem, you should probably talk a little bit about the power requirements and things for that.
Yeah, the quick answer is yes. For the outdoor access point, it's a 700 series outdoor access point. It has almost the same software features as the indoor 700 series outdoor access point. It means that you get dual band, concurrent 2.4 and 5. You get 1750 wireless AC with 3x3 antenna. And in that support tab video, we talk about, it has the same band steering, it has the same fast roaming features, so it will work seamlessly. It's overseas enabled. The one caveat, or the one thing that we did from a design perspective, it's because it's an outdoor product. In the outdoors, signal travels really far. Because there's less obstruction, there's less interference, or not, there's more interference but less obstruction, so it doesn't degrade that much. So what we found in testing is that you will be sitting 400 to 500 feet away from the access point. Your phone will get 2 bars of Wi-Fi coverage, sometimes 3 bars, because it travels really far from the access point. But your phone or your tablet is limited in its output power. So think about it as its mini access point. There's a radio inside that phone that needs to transmit power. So the maximum power for that phone is 22 dBm. And when you have a really high powered access point that's reaching really far, and the signal strength coming from the phone back to the access point is not as high, then you end up with 2 bars of Wi-Fi, but you're spinning because your signal, you cannot talk back to the access point. So what we've done with the outdoor is that we tuned down the power of that product to be maximum 22 dBm. So at the very least, it matches those devices in terms of output power. And now you get a better performance, effective performance. So you not might get as much coverage, but at one point you end up with a lot of garbage coverage, that you get a lot of coverage but you can't talk back. So that's what we've done with the outdoor product. But from a installability perspective and from an architecture perspective, it's really plug and play. It will be another access device on your access layer.
Alrighty, that's about as much time as we have for today. There are quite a few other questions that have come in, and of course, like always, we'll pass this on to AHAM's group, and those guys usually follow up within a day or two on answering any questions that we didn't have time to cover. I do want to add one little bit of information, a personal part of information to this is that every time I sit in one of these webinars and host these for AHAM, I learn tons and tons of things that I did not know about networking. I'm sure the same is with you guys. I do want to give you one other bit of advice is that we did a previous webinar called The Truth About Wi-Fi Speeds, and probably it is my most requested link that I get via email is guys say, hey man, I want to look at that thing again. Could you send me the link? So I've got to give you guys this advice. Go to our website, go to our product pages, log in with your username and ID, go to any of the access points, any of our access points, and you'll see a video under the support tab called The Truth About Wi-Fi Speeds. And AHAM did an excellent job of being able to explain exactly what you can expect with Wi-Fi technology. I think if you take that webinar, you'll be able to speak to your customers in a really easy to understand way to explain to that customer why they're not getting the posted speed of what they might be expecting. It also gives you the ability to understand fully on how to properly design a true Wi-Fi network. So again, a little bit of advice, please take the time when you do have some time to take a look at that webinar. Again, it's on the product pages, on the access points, under the support tab, look under videos, The Truth About Wi-Fi Speeds. Again, thanks AHAM for another great webinar. We are going to follow up this in a day or two, probably Monday or Tuesday. You'll get a email follow-up. It's going to have the coupon code for the offer that we sent you in the invite, and we're also going to put a link to this recording session. It takes us a day or two to process it and get it posted. So look for this on Monday or Tuesday of next week for that follow-up email. Also, as a follow-up, please take a brief minute to fill out our survey on the exit of the webinar and let us know what you thought of today's presentation and what other webinar topics you're interested in. On behalf of AHAM and Arachnus Networking Products and SnapAV, we thank you for taking the time to join us today. Have a great day and happy installing.